I want to help you get a better understanding on the intermediate value theorem. So we'll do that first by doing a very basic proof using the theorem. So we'll just call this a basic proof using the intermediate value theorem. Okay? So let's prove that there is a C value, C for constant. There is a C value in the open interval between 1 and 2. So prove that there's a C in this interval such that 1 minus 2C plus C cubed equals 4. Okay? So let's prove that that's true. All right, so you know what? And I probably should have said use the intermediate value theorem to prove that, just as a hint as to how to do this. So the first thing you need to know is what the intermediate value theorem is. I'll assume if you need to go to review that now, go for it. I'll kind of talk about it as I go here, but I'm not going to write the theorem out, but I will use it. So we'll label this proof. Proof. So we're going to start our proof here. So if I want the intermediate value theorem, I need a function that's continuous on a closed interval, okay? So I've got a hint about my closed interval. It's probably the closed interval from 1 to 2. So I need a function. So why don't we let f of x, I've got to create a function because there's not one here. So what I'm going to do is I'm going to use this guy for my function. So let f of x equal, instead of c, I'm going to replace those with x's, 1 minus 2x plus x cubed, okay? So there's our function. We've created it so we can use the intermediate value theorem. Now what has to be true about this function for the intermediate value theorem? So it needs to be continuous on a closed interval. So note that f, it's a polynomial function. Note that f is continuous everywhere, right? The domain of this function is all real numbers. So it's also continuous on that domain because it's a polynomial function. So it's continuous everywhere. So clearly, and you can use your own words as you go through this, make it your own narrative, just you have to hit the critical parts. You have to create a function. You have to convince me that it's continuous on the closed interval. So clearly, f is continuous on the closed interval from 1 to 2, okay? So that's the hypothesis of the intermediate value theorem. The next thing we need to do is look at f of 1 and f of 2. Those are the two y values that the intermediate value theorem guarantees we can hit every y value between. So f of 1 equals, well, you plug 1 into your function. So f of 1 is 1 minus 2, so that's negative 1, plus 1, which is 0. F of 1 equals 0. And f of 2 equals, so now we plug 2 in, so I get 1 minus 4, which is negative 3, plus 8, which is negative 3 plus 8 is 5. Okay? All right, so we have our two y values. All right? Now what we're wanting to happen is we want the function to output 4. That's what this is saying up here. We want the output of the function to equal 4 for some c value. Well, because 4 is between these two y values, so since 4 is between f of 1 and f of 2, right? The intermediate value theorem says for every n which in this case, the n we're picking on is 4 because that's the output of the function, for every n between f of a and f of b. So we've got an n that is between f of a and f of b. So we're not really focused on the 0 and the 5 when we write it out, but we understand that this value is 0 and this value is 5, therefore 4 is between those, okay? So since 4 is between f of 1 and f of 2, the IVT says, let's cite the theorem that we're invoking, says there exist, well, what letter are we using here for our x value? Well, in this case, we're using c, right? So the IVT says there exists a c in the open interval, right? The IVT guarantees an x value in the open interval. So c is in the open interval from 1 to 2, such that, and what's the conclusion of the IVT? That f of that c value, which is an x value, such that f of c equals our n value, which is the 4, the y value between f of 1 and f of 2. Okay? So this is where the IVT leads us. F of c equals 4 for some c between 1 and 2. Now, we need to conclude this, though. Okay? Well, what is f of c? F of c is the function that we created with c in as the input. So f of c turns into, so I'll write therefore, 1 minus 2c plus c cubed is f of c, and we know that equals 4. And that's the end of the proof. We've shown that there exists a c in the open interval such that 1 minus 2c plus c cubed equals 4. And we'll indicate the end of the proof as such. All right, so really work on your language, really work on making sure to state the hypotheses. One thing I'll point out is that I didn't emphasize that f of a and f of b are not equal. Remember, that's a hypothesis in the intermediate value theorem as well. But f of a does not equal f of b. That kind of comes out here. If f of a and f of b were equal to each other, we couldn't squeeze 4 between them, right? So that's already sort of implied here as we use the IVT for this proof. But make sure you understand all the nuances of the mathematics happening here, and you can sort of interchange some words if you like to. Just be careful about the words you use.